I got a treat for you tonight. Nice short video here. We're going to learn how to construct a perpendicular bisector. One of the most important, very, very, very important construction, because you kind of use this in other constructions. And this is kind of the basis for everything else we do. Now, I'm going to spend a little bit of time here going over the vocabulary, and because it's so important to understand. When you hear perpendicular bisector, you have to know, what is he talking about? What does that even mean, right? So perpendicular bisector, it's got two words, two meanings. Put them together, and then you'll understand it better. What does perpendicular mean? Perpendicular means intersecting to form right angles. So that's what it says right here. So basically, a perfect T, just like that. That's perpendicular when two lines do that. If they're like this, they're not perpendicular. If they're perfect like that, they're perpendicular when you see right angles. All right, so I'll draw you perpendicular. I'll just do it on the side here so you can do it on your paper. Boom. Oh, I know that's freehanding. Boom, boom, with a right angle. Okay. Well, if we got one right angle, they're all right angles, right? They're all right angles there, okay? These lines are perpendicular. So we're going to be constructing perpendicular lines. So one's going to go this way, one's going to go this way, all right? They're going to be right angles in the middle. And then bisector, we learned on last lesson what a bisector was, cuts in half, right? So, but now we're going to bisect a line segment. So we're going to have the line segment, two endpoints, and we want to be right down the middle. So we want to be right at that midpoint. So think of endpoints, midpoint. Endpoints, midpoint. Got it? The line's going to go right through that midpoint. When we do a perpendicular bisector, we're essentially also doing a midpoint. So if you ever need a midpoint for a construction, just do a perpendicular bisector. That's why I said this perpendicular bisector construction is going to be used elsewhere. Very, very, very important. All right, so perpendicular means intersecting to form right angles. Bisector means to cut basically in half, cut into two equal parts. And perpendicular bisector means both. Intersecting at the midpoint, okay? So now we're going to investigate that. We're going to do this construction here. So we're given a line segment, AB, and we want to do the perpendicular bisector. Very, very, very simple. Very simple. Put your compass on A, compass point on A. Open up your compass. Now here's the thing. It's got to be more than halfway. More than half. As long as it's more than halfway. Oh, that's a lot. As long as it's more than halfway to A to B, you're fine. Okay? So now that is more than halfway. I'm going to do one circle here. And again, I'll just stop. You could go and do the full circle. You don't have to do a full circle. You could just do the arcs. All right? And then same setting. Look, I'm not changing it. Same exact thing. I'm going to flip it around though. All right? Put that compass point on, oops, don't want to move that picture. Put your compass point on B and swing another arc or circle. Look at that. So what you just did is you created 2 points where the arcs intersect. Boom, boom. Those 2 points connect. And watch how they connect. Look at that. Perpendicular. See how it's perfectly up and down? You can mark your right angles there. And guess what this guy is right there? Change colors. Oops. Oops. Change colors to green. Guess what that guy is right there? What's he called? He's called the midpoint. So we're going to label it M. Okay? So we actually constructed the midpoint. We constructed the perpendicular bisector and the midpoint at the same time. We did 2 constructions in one. Okay, so there it is. The perpendicular bisector is the red. So I'm going to label that. Okay. The segment, the red segment, is called the perpendicular bisector. All right, very, very important. All right, and then that's pretty much it. We're just going to go through a couple things right here. Now that you saw it, so here's basically what it looks like without the arcs, okay, right there. Based on your, examine the following pairs of segments, AC and BC. So let's do that. Okay, so examine the segments. So AC with BC. okay? AD with BD, AD with BD, and AE and BE, AE and BE, okay? AE and BE, and I freehanded those. Just wanted to color them for you. So that's what they're talking about here, is the comparison red to red, blue to blue, green to green, okay? Based on your findings, fill in the observations below. So based on, and this is a perpendicular bisector, this guy right here, going up and down is the perpendicular bisector. Any point on the perpendicular bisector of a line segment is blank from the endpoints of the line segment. So any point on here, C, D, E, F, G, I'll keep going, H, I, J, K, L, M, N, O, P, right? You could keep going forever because guess what? There's an infinite number of points on that perpendicular bisector. Just because we stop drawing doesn't mean it stops. It keeps going forever. It keeps going forever. So there's an infinite number of points on that thing. So what they're saying here is any point on the perpendicular bisector, any point on it, any of these green points here, they are what from the endpoints of the line segment? What are they? So let's take F, and let's do F to B and F to A. Let's do G to B and G to A. Let's do H to B and H to A. See that? That's what's happening. So what do you know? Red and red. What are they? They're what? They are the same distance. They are the same distance. So any point on that perpendicular bisector, if you go to the endpoints of the original segment was AB, right? You take any point on that perpendicular bisector and go to the original, it's going to be the same distance. That word is called equidistant. Equidistant means equal distance, same distance. Got it? Okay, so that's what we want to put on this line here, equidistant. Equidistant. So any point on the perpendicular bisector of a line segment is equidistant from the endpoints of the line segment. Very important observation to take from this video. See you tomorrow.